Welcome to the introduction to the mainframe architecture and the mainframe paradigm. My name is Philipp Brune from Neu-Ulm University of Applied Sciences. When we think about the mainframe as an idea, not only as a certain hardware, then we should think about the difference between scale up and scale out. The mainframe paradigm means that we have a classical system which has multiple CPUs, and these CPUs are symmetrically accessing the main memory and have the same rights to access the main memory, as you can see on the left-hand side. So this is a classical mainframe architecture. In the mainframe architecture, we have one big server system, which has, of course, CPUs and RAM and storage disks, but all the CPUs share a common main memory, a common RAM, and can access this with equal rights. This means that in such a system, parallel processes, which we need, for example, for transaction processing, are able to know about the status of other parallel running processes in the same system, since they share the RAM, they share a common memory to exchange information in a very efficient way inside the machine. On the other hand, when we look in research, in computer science research, and also, of course, on IT practice today, the dominating paradigm is the cloud or grid paradigm. That means that we have, in such an environment, we would have a big number of servers, which are, every server itself is rather simple compared to, for example, a mainframe. So I illustrated this here by just giving them one CPU. Of course, in reality, they might have also a few CPUs. But these servers are rather simple. They are commodity hardware, and they are connected to each other using a network. Okay, so they communicate over a network. And this could be a high-speed network, but it's still a network outside the individual boxes. And they might share as well a common storage, which they access over network components as well. This paradigm is the typical paradigm that we have in all the cloud and internet providers like Google, Amazon, and so on, where you can, even as a customer, get rather cheap access to some of these virtual servers that then might be connected to such kind of cluster. In this case, we have the so-called scale out. That means if you want to increase the performance and you want to increase the capacity of the system, you can just add further servers to the network, and an increase of computing capacity is achieved by adding more servers to the network. This is called scale out, in contradiction or in opposite to the scale up, which we would have in the mainframe paradigm. Scale up means if you want to increase the performance of the system, you can put in more RAM, you could put in more CPUs in this one big box. And this increasing number of CPUs may communicate internally. And the question, of course, is now why, for example, Google doesn't need a mainframe, or Amazon, or all the other internet providers. And the answer to that is Amazon and Google and all the internet companies, they have their core applications written in a way that they perform well on such kind of distributed grid or cloud cluster architecture. But if you look at businesses where you need transaction security, where you need the possibility to execute business transaction in a safe way, then this requires that parallel running transactions know the state of other transactions, and there is the need to share information. And this is, of course, achieved much better in an architecture where you have a shared main memory. And this is the important concept of the mainframe, for example. So mainframe-like architectures are scale-up based scalable architectures. And this is what we want to sort of look deeper into in the following. When we talk about the mainframe paradigm, by mainframe we mean a high-end server supporting concurrent operation of a large number of users, a large number of different parallel running transactions, as well as different operating systems. This server usually has the capacity to host thousands of users and applications simultaneously, so it's a big central machine and it's usually used as a central data store of an enterprise data center as well, where all other applications access the core data of the company. For example, in the automotive industry, we have the product data, for example, in this kind of core system. And so it's a server with a maximum number of hardware capacity, and since it's a central, crucial and critical system, of course, the server needs to have the maximum possible availability, guaranteed availability and security. So these are the core properties what we classify as a mainframe system. Of course, when we talk today about mainframes, we usually refer to a certain architecture, a certain hardware, and this hardware architecture originates from the original IBM S360 generation of computers, which was first presented in 1964. And the 360 in the name stands for 360 degrees, so it was considered a general purpose machine for different kinds of customers, for different kind of tasks and workloads, scientific computing, business computing, and so on, which before that was usually separated and addressed by differently individually created computers. And over the years, this original S360 architecture evolved, and it was renamed, and it evolved to the what we call today the Z systems architecture. So this is a long-term history of a certain CPU and hardware architecture, meaning that these machines have a specific instruction set and a specific CPU architecture and system architecture. In the past, different companies offered compatible systems for these kind of machines. Since IBM released the specification of the hardware in a document, and so it was possible to build compatible systems by other vendors. But during the decades, all the others sort of went out of the market except Fujitsu. Fujitsu, formerly Siemens Fujitsu, still is selling mainframe systems that are originating on the same architecture. They are based on the S390 generation of the mainframes, and we will learn also a little bit later about that. So if you look at the picture, you see that from the original S360 to the more modern mainframes, it's a long way, and these systems don't look very similar, but still the modern mainframe is fully backward compatible to the original one. So you could run, in principle, a binary program written for the original S360 machines on a modern mainframe as well, if you need to do that. So this is the hardware architecture. It has the longest standing backward compatibility of all existing architectures today. So what is typical for mainframe workloads? So mainframes are a high-end technology, and high-end technology means that it's also very costly technology, and this means that it's of course used for only the important applications. So all or many large mission-critical applications of traditional enterprises run on mainframes. The mainframe guarantees the highest availability, a very high, or the possibility to process large data volumes, high data volumes, since it is an architecture that was optimized for input-output operations, for I/O operations from the beginning. It enables, it features a very high transaction throughput. So the mainframe itself is not necessarily mainly a CPU-centric architecture, which is very focusing on quick calculations, for example, but it's an architecture that is balanced in a way to achieve the highest possible throughput of parallel running transactions. And this involves more than the CPU, it's the CPU and the memory and I/O as well. And of course, it supports special security requirements, special security features like encryption and other things in hardware. Examples for typical mainframe workloads are, of course, the traditional mainframe applications are bookkeeping systems, as we know from aircraft industry, planes, bookings, travel bookings, financial industry, and all these industries where you have the need to do very fast and consistent bookings. On the other hand, we have the mainframe as a centralized data store, centralized database server for all important enterprise data. As I said, for example, in the car manufacturers. The mainframe can also run SAP, ERP or CRM application servers, which then could be or is a business critical central application for many companies as well. And here, typically for the application servers, Linux on the Z systems, for example, would be used. Data warehousing, data mining, artificial intelligence, big data analytics are typical workloads that could benefit from the mainframe architecture, more modern workloads. And of course, in recent years, cloud computing, cloud hosting, the possibility to run the backends for mobile services, highly scalable backends for mobile services, for example, in retail business, are workloads that could run on the mainframe. And of course, blockchain is also an interesting hot topic at the moment because blockchain applications benefit a lot from cryptographic features which the mainframe architecture supports in hardware. If you look at the typical or the architecture of a modern mainframe system, then you can see that it is designed for the highest possible availability, which is crucial for mission-critical applications. And so the hardware is highly redundant. Everything is redundant in the mainframe box, the CPU, the RAM, and it allows to configure the resources at runtime, to assign resources and move resources around between different parallel running applications at runtime without, for example, shutting down the system. And by coupling multiple mainframe boxes, which are called CRC or KEC, to a so-called parallel sysplex, which is kind of a very sophisticated cluster mechanism, it allows even to have systems that achieve the highest possible performance availability of 99.99999%, so the 5 nines, and this is the maximum you could get. Because these systems allow, for example, to move around workloads at runtime without shutting them down if one of the cluster partners breaks down. The CPU architecture of the modern Z14 is the most recent generation of the mainframes is a 64-bit architecture. The one CPU has 10 cores, and these cores are called PU, processing units. And it's possible to have about 170 PUs available to the customer. There are some more for internal administration things. This generation runs at 5.2 gigahertz clock speed, and it still is a complex instruction set computer. So the mainframe architecture, the binary instructions are complex instructions. So the mainframe processor has a very, very large set of machine instructions with very special instructions for encryption, for binary coded decimal arithmetics, and for many other special things that we will go a bit deeper into in the following units. One important feature of the mainframe is that you can partition the system, and you can partition it in different sort of virtual machines. And these different partitions then can run different operating systems. So every partition can run another operating system and serve as a sort of virtual server, and resources may be allocated dynamically between these partitions at runtime. This is a virtualization mechanism that's built in the hardware and in the firmware of the system, and allows to divide a physical machine into multiple servers even before you install an operating system. One important thing is that how we use a mainframe. Traditional mainframe customers typically think of mainframe using a terminal. A terminal which is called the 3270 terminal, which you can see on the left-hand side. This is a classical terminal, a physical device, a sort of a dumb input-output device that is connected to the machine, to the central machine, where the user can just enter data and get data. And this in the past used to be a dedicated hardware, so it's really the device that you can see here. But of course today we don't have these devices anymore, but we use software emulation of these classical text-based screens that are used to interact with the system. So that was the classical approach, and for many decades sort of defined for the users what the mainframe looked like. But of course today users are not mainly interacting with these kind of terminals with the system anymore, but since it's a high-end server, of course we have other features. Usually from an end user's perspective, the mainframe is hidden behind web front ends, behind mobile apps that call the mainframe transactions, for example using web services. And for the developers, typically we have modern tools like Eclipse to program, and of course all the other tools that a developer is used to, FTP and SSH login and so on. And so today this classical terminal user interface is mainly used by administrators and people who are directly configuring, for example, the system. Finally, a short overview about operating systems. When we talk about the mainframe and thinking, okay, what kind of operating systems are running there? You will see that there are other operating systems than Linux and Windows, which you might know from your daily life. So on the mainframe, we have operating systems that have a long time history. These are IBM-specific operating systems, but also, of course, we have Linux on the mainframe, which is very important nowadays. And of course, there is another operating system for the Fujitsu, formerly Siemens, line of mainframes, which is called BS2000. And you will also get a short introduction to that during the course. The traditional IBM mainframe operating systems start with so-called MVS, the MVS family of systems, which today it is called ZOS. And then, of course, we have something that used to be DOS VSE, which today is called ZVSE. And we have the VM. The VM is a hypervisor virtualization environment that we will also have a deeper look on later. Okay, so these are the three families of systems. Over the years, the features and also the name has changed, but it's more or less the same line of operating system until today. The most important one is ZOS. This is a flagship operating system for the mainframe, which features all the highly special features like parallel sysplex and all the other things. And beside this, of course, today mainly Linux is very important. VSE declined over the years. Nevertheless, there are still some installations running, but it's not as important. It used to be the sort of the small brother of MVS for, let's say, smaller companies, for example. And VM has became more important in the recent years as well as a virtualization environment to host multiple Linux instances. So this is the family, and here you can see also the evolution of the hardware, starting from 16 or 24-bit for the original S360 until the 64-bit today. And this should be a short overview on the platform and the architecture and the history. And in the following chapters of this course, we will now look at all these different technologies in more detail. Thank you very much.